Zeal Education Society, redefining excellence.
Hello, good morning to everyone. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the permanent magnet stepper motor, its construction and applications, principle of working and applications. In the today's video lecture, we are going to learn the permanent magnet DC motor and permanent magnet DC motor. Let us have a look at a permanent magnet DC motor. Now see the construction. See the figure B. This is the conventional DC motor and figure A is the permanent magnet DC motor. In a conventional DC motor, the stator has four, here it is, the stator has four projecting poles, or we can say field poles, on which field winding is wound. And when excited by a DC source, it will produce alternate north pole and south pole. So it will produce the stationary magnetic field. Okay. Now see, observe the rotor. Okay. It will produce the stationary magnetic field. This job can be obtained by fixing the permanent magnets on the stator frame as shown in the two pieces, or it may be continuous throughout the stator in a complete ring. Okay, and it serves the same purpose as that of the salient poles and excitation winding or a field winding. Okay, then the see the rotor has a slots, then the rotor armature winding and commutator and process. So the rotor is similar to rotor of the permanent magnet DC motor is exactly similar to that of the conventional motor. Okay. Now the armature is similar. Okay. The next point is, so what are there are three types of permanent magnet materials are used, having high residual flux density B and high coercivity. The first material is Alnico or Alnico. It is an alloy of aluminum, nickel and cobalt. It is costlier one and used for motor ratings 1 kilowatt to 150 kilowatt. Another type of permanent magnet is ceramic, that is ferrite magnet, and generally it is cheaper one and therefore used for fractional horsepower motors or very small motors also. Then the third one is rare earth magnet, that is samarium cobalt and neodymium iron cobalt, having very high energy density. It can be used for a small as well as large motors. Now see the working. For the working of this motors, the principle of working of the permanent magnet DC motor is exactly similar to that of the conventional motor. Only difference is that instead of conventional way of producing the field, here it is the permanent magnets are used on the stator. It may be in 2 pieces, 4 pieces or a continuous ring. Now for its operation, it works on 6 volt, 12 volt, 24 volt DC supply. The DC supply may be obtained from the battery or a rectifier or a chopper circuit, or a rectifier. It can be obtained from the rectifier. Now see its performance characteristics. Now look at the NT characteristics. Torque and speed is here. The speed torque characteristics is a straight line and little bit drooping in nature. And because of this kind of speed torque characteristics, such a kind of motors are very suitable for the servo applications or servo motor applications. Then see the input current. The input current of the motor goes on increasing as the torque increases linearly or a straight line relations. Then the efficiency of such a motor is higher because of absence of the field circuit. Then the speed control. How to obtain the speed control? Conventional motor speed can be controlled by the armature voltage control and the flux control. But we have a permanent magnet here, therefore the flux is constant. We cannot obtain here the flux control. Therefore, armature voltage control method is generally used. Means by reducing the armature voltage, and this can be obtained by using the chopper circuits. And generally the speed requirement is less than the rated speed, and that's why this is also preferred, and there is no alternative also. Then the next point is, what are the disadvantages of this? As its field circuit is continuous on, irrespective of whether the motor is working or not. Such motors are totally enclosed to avoid or collecting the junks, magnetic junks from the neighborhood of it. Thereby the magnet can become weak also. Another factor is, as the motors are permanently enclosed, there will be more temperature rise. However, there will be no such issue, temperature rise issue, if such motors are used for a short period or a short duty. Now, there may be a chances of wipe of the magnet or demagnetization of the permanent magnet because of the heavy armature reaction MMF or wrong connections. Now, let us see the applications. Now, 12-volt motors, 12-volt DC motors are used in the driving automobiles like heaters and AC blowers, wipers, then power windows, automatic windows, mirror adjustments, fans and power steerings, radio antennas, etc. in automotive industries or automobile industries. It can also be used for fuel pumps, marine engine starter, wheelchairs, etc., toys industries, toothbrush, food mixer, ice cracker, shoe polisher, portable vacuum cleaner, etc. It can also be used for a portable electric drill in medical applications, etc. Now see the permanent magnet AC motors. Permanent magnet AC motors are nothing but the permanent magnet synchronous motor. The synchronous motor stator, the stator construction is similar to, I have already stated the construction of synchronous motor stator is similar to the alternator and similar to the 3-phase induction motor or a single phase induction motor. The construction is same for the stator. Now see the rotor constructions. Rotor is made up of permanent magnet, of rare earth permanent magnets, and instead of using the projecting poles in a normal cases or salient poles in a normal cases in a synchronous motor. The figure shows the 2-pole and 4-pole permanent magnet rotors. The stator already we have discussed. So this is a 2-pole rotor and this one is a north pole. Here it is south pole, and within the magnet the flux flows from the south pole to the north pole. Here will be air gap outside the rotor, and then there will be a stator circuit. Okay, so these are the permanent magnets. Then this figure shows the 4-pole permanent magnet rotor. Now within the magnet, the magnetic flux flows from south to north, and it completes its path via the air gap to the south again. So it is shown like this. These things, and rotor is just like a spiral cage rotor, and it has no field winding, no slip rings and buses, so it is more robust and reliable. And therefore this motor works like an induction motor, start like an induction motor. Thus for small motors, dual starters may be used, and it can be started as an induction motor, then it pulls into synchronism. The synchronizing torque generally required is 1.5 times the rated torque. As the field winding slip rings and buses are absent, it has a higher efficiency and power factor. The motor output of such a motor ranges from 100 watt to 1000 watt. Now, what are the applications of such motors? They are used in robotics, machine tools, actuators, and in high power applications such as industrial diodes, vehicular propulsion of the synthetic fiber drawing, where the constant speed requirement is there. We'll stop here. In this video lecture, we have learned both permanent magnet DC motor and permanent magnet AC motor. We have seen their construction, principle of operation, and their applications, etc. Thank you very much.